Hi, I welcome you all to my channel Econo Pathshala. Today I am starting a new series of sessions on econometrics. The main motivation behind starting this series are the following. First, econometrics has emerged as a very popular branch of economics learning. First, the research undertaken in universities at PhD level or research undertaken for publishing papers in professional journals are heavily using econometrics nowadays. Secondly, for decision making at the government level, say for Government of India, different state governments, Reserve Bank of India, wherever economic analysis is involved, there is heavy use of econometrics for undertaking empirical analysis, which is feeding to policy decisions. Similar thing is for business decisions at the private corporate level also. Thirdly, nowadays, econometrics has become part of BA level curriculum in most of the universities and colleges in India. But what I observed out of my teaching experience at PG level in Pondicherry University, many of the students who are joining at PG level are lacking adequate, I'll not say adequate, even reasonable understanding of econometrics for various reasons. So this is my endeavor to basically sort of disseminate information on concepts, methodologies, and application of econometrics to a larger audience. Now, what is econometrics? Econometrics is basically, it is, uh, it's not transiting. Yeah. Yeah. So econometrics is basically economic measurement, right? So this suggests that this is the tool which are used for empirical economic analysis. I'll explain with some examples in the next slide. So now let me tell you that econometrics applications are not only confined to the economic analysis. It has now applied widely in finance, in social science, even in medical science. So, although the name is econometrics, but it is applied for empirical analysis and research in a wider field of disciplines. So, let me explain how econometrics is helpful using a couple of examples from economics. In microeconomics, there is a principle called law of demand. So law of demand suggests when price of a good rises, the demand or consumption purchase of that good declines. So assume, let us take example of apple. When price of apple will be rising, say it doubles up, naturally the households will be consuming less of apple. They will substitute other fruits, maybe orange, maybe guava, right? Similarly, when price of apple declines, then the demand for apple will be increasing. So this is known as the principle of law of demand. So if I want to mathematically specify the law of demand, I can do that using the equation in front of your screen, which is Q is equal to A minus BP, where Q is say demand for apple and P is price of apple. So here A is the intercept and the B is the slope coefficient. So as you can see, the sign before B is negative. So this is suggesting that when price of apple is rising, purchase of apple declines. When price of apple falls, purchase of apple increases. That we can basically talk in terms of any goods and services a household is consuming. Now, what is important to remember is the theory doesn't specify what is the value of B, right? So if a researcher is interested to know does exactly rise of price of apple leads to decline in the consumption of apple, then one need to empirically estimate it. One need to know what is the value of B. Is it negative? Or secondly, if it is negative, is it very strong, high value numerical value for B, or it is weaker? For that we need to undertake an empirical analysis where use of econometrics is a must. Now let me go to another example drawing from macroeconomics, which we call Keynesian consumption function. So Keynesian consumption function suggests when income of a household increase, the consumption spending of the household will increase, obviously. So when I get a pay hike, naturally I feel richer, so I feel like spending more, right? And the Keynesian consumption function also suggests that the rise in consumption spending due to a particular amount of rise in income will be lesser than the rise in income. What I mean is, assume rise in income is given by del y, where y is income. Say it is 1000, and rise in consumption expenditure is given by del c. So del c will be less than 1000. That is, rise in consumption expenditure will be lesser than 1000, right? So if we want to mathematically specify Keynesian consumption function, I can use the equation given in the bottom of the screen, which is basically C is equal to A plus BY, where C stands for consumption spending of the household, Y stands for income of the household, and A and B are intercept and slope coefficients respectively. So here B measures the change in consumption spending due to change in income, and this B popularly referred as marginal propensity to consume, or MPC. Its numerical value as per the Keynesian consumption theory is should be greater than 0 and lesser than 1. So here again, although theory suggests that there is a positive relation between consumption and income, as a researcher you may be interested to verify, is it true in reality, right? So then you are interested to undertake an empirical analysis and measure the numerical value of B. Is it positive? Okay, and then even if it is positive, is it greater than 0 and less than 1, right? So as a researcher you will be interested to examine that. So in the next slide, yeah, here I have plotted the per capita income and per capita consumption spending of drawing from data from India. Okay, so as you can see, the per capita income of in India from 1950-51 has witnessed a upward movement, and similar trend is also observed for private consumption spending, household consumption spending. So it appears there is a positive relation, right? So if you are interested to empirically estimate the relation, right, perhaps we can do that. First of all, to understand the relation between private income, household income, and uh, household consumption expenditure, I have plotted them in this scatter plot. The blue dots here basically capture the relation between per capita consumption spending and per capita income, drawing data from India for the period 1950-51 up to 2024-25. So as you can see, these scatter plot, that blue dots broadly reflects there is a positive association between consumption spending and per capita income, right? But to get a measure of B, the coefficient B, what I have done, I have fitted a curve which best explains the relation between the consumption expenditure and income out of the scatter plot, right? So this straight line basically can be specified in the form of a linear equation which is given here on the screen, which is y is equal to 0.61x plus 3382.5. So here the number 3382.5 is a numerical estimate of A of the Keynesian consumption function, coefficient A, that is intercept, and 0.61 measures the slope coefficient B, or MPC. So what this estimation suggests? This suggests that when the say per capita income increasing by say 1000 rupees, then consumption expenditure of a typical household increases by 6100, on an average, right? So using econometrics we can fit a line to the scatter plot as done in the screen and get a numerical measure for B, right? So that's how is, econometrics is helpful to provide an empirical estimation for a economic relation, right? The relation between income and consumption, which is basically derived from Keynesian consumption function. If we want to empirically verify, then we can use econometrics and estimate an equation like this. So, in a series of sessions in the future, I'll be basically explaining the very methodology of econometrics, how to estimate, a regression model using econometrics, and how to interpret the results, right? So now let me come to the next relation between say banks NPAs and credit growth. So the intuition behind the relation is, what is NPA? NPA is non-performing asset. So non-performing asset is an asset or a loan which the bank has given, but it is not receiving loan repayments or interest payments, okay, as per the due agreement. Okay, so for example, when a home loan is given and the principal amount and interest payments are regularly paid back through EMIs, okay, it is called a standard loan. Okay, but when these EMI is not paid for more than 3 months, more than 90 days, then this loan is classified as NPA. Now, how NPA is likely to impact the credit growth of a bank? So basically, NPA suggests, the bank is not receiving income out of a loan it had disbursed in the past. So this loss of income restricts the fund availability to the bank. So it restricts its ability to give a fresh loan. Secondly, on NPAs, banks need to make provisioning, higher amount of provisioning. So if an asset is becoming NPA, depending on the type of NPA, the bank has to set aside some amount of income out of its other loans on which it is regularly receiving EMIs, right? So that way it is an additional burden. Thirdly, when the banks are suffering from high NPAs, the bank managers will become very stringent, very strict in terms of credit appraisal. So getting a loan from a bank becomes difficult when the banks are suffering with high incidence of NPAs. So from this perspective, we will expect that when the NPA level of a bank rises, its credit growth will be adversely affected. Okay, it will decline, right? So in this graph, I have basically plotted the information on credit growth and NPA level of several banks, Indian banks, for 2016. I think it is restricting to public sector banks and some big private banks. As you can see from this scatter plot, interpretation about the relation between credit growth and NPA is not that obvious, not that clear. That can be subjective, right? So the scatter plot doesn't give a clear idea about the relationship between bank credit growth and NPAs, or the impact of NPAs on bank credit growth. So if you're using econometrics, we can basically fit a straight line, okay, and then following OLS, ordinary least square, a methodology which is used to estimate econometric relations, right? I mean, using econometrics relation, economic relations using econometrics. So in this graph here, I have this straight line which is negatively sloped, suggesting there is a adverse impact of NPAs on credit growth, right? So, and this empirical relationship is specified by the equation y is equal to minus 1.12x, and there's a typo error here, x is missing. So that B coefficient is here negative 1.12 and intercept coefficient is 7.38. This relation suggests that when NPA of a bank is rising by 1 percentage point, the credit growth of a bank declines by 1.12 percentage point on an average, right? So this way we can establish empirical relation between NPA and credit growth using econometrics. Now, for using econometrics or application of econometrics, what are the things required? First, we need to learn the methodology of econometrics. For learning methodology of econometrics, there are basically three main ingredients. First, there has to be economic theory, like Keynesian consumption function or law of demand, okay, which basically provides the intuition behind relation between economic variables, okay. And these economic variables, I did not limit to economic analysis. Depending on your field of research, if you are from sociology, if you are from commerce, or you are from medical sciences, right? So using your theories from your own discipline, you can specify a econometric model. So basically, economic theory helps us building or constructing the econometric model, about which I'll be discussing in the following sessions, not today. And the second thing is mathematical methods. So basically, mathematical methods, particularly matrix algebra, calculus, are used for sort of estimating econometric models. Okay, these are basically these methods work behind the estimation procedure used in econometrics. And thirdly, statistical tools. Statistical tools are used for hypothesis testing. For that, understanding of different types of distribution, normal distribution, t distribution, f distribution, etc. are required. So this way, econometrics uses economic theory, mathematical methods, statistical tools. In that sense, it is an interdisciplinary subject. So these three are main ingredients for developing methodology of econometrics or explaining methodology of econometrics. Now, for estimation, for application, what you require two things. First, you require data. Okay, like I use data on consumption, data on per capita income to estimate Keynesian consumption function. Okay, or data on NPA, data on bank credit growth. So first you require data on those economic or financial variables for which you are trying to find estimate the empirical relation, right? And then you require econometric software. The very popular softwares available in the market are eViews, Strata, SPSS, and some traditional people use RATs. So these are the softwares which are used for estimating econometric relations, right? Now coming to the econometric methods, there has been a evolution process for these methods. Initially, the methods which are used are referred as classical econometrics. You know, uh, we have just in a scatter plot, I had showed the relation and tried to fit a straight line to the scatter plot. Now, when I have many variables, not only one variable affecting consumption spending, say in addition to income, the wealth of an individual, the general prices, number of family members of the household, these variables also affect the consumption spending of a household. So this way, to be realistic, we'll be using multiple regression model where more than one right hand side variables will be there to explain the behavior of the left hand side variable. Okay, so the classical econometrics deals with these basic methods of econometrics, where we'll be discussing about the very specification of the model, different assumptions behind the model, and how we can draw inferences about the population parameter based on the sample estimates. So ultimately, the econometric estimation which you will be undertaking, that is based on sample, okay, data derived from a particular sample. Now, how to migrate from sample to the population? Okay, so when we talk about a relation in general, like how change in income impacts consumption, that is an inference we are making for in general for any household. But we don't have data for all households. We collect data for sample households, and from that we estimate an econometric relation. Using that, we derive inferences for the entire population, okay, for in general. So the classical econometrics will be learning all those procedure. Now time series analysis is a special branch of econometrics which meets this specific requirements of a time series. So basically we'll be discussing then, as we saw earlier, the consumption expenditure and the per capita income has a upward trend, right? So the positive relation which we observed between per capita consumption and income, is it because just these two series move upward over time, or actually there is a relation between them? So time series analysis will try to segregate the increasing trend aspect and try to find out whether there is actually relation, true relation between income and consumption spending, right? So then finally we'll come to panel data analysis. So here we have data which has a time dimension as well as a cross section dimension. So I gave the example of bank NPS and bank credit. So there I had collected data for 2016 for several banks. Now if you want to estimate the relationship for those between NPA and bank credit for those banks, drawing data from 2016, 2017, 2018 onwards. So here you have data which is pooled, okay, over time series, over time, and as well as across different units of banks, right, or different banks. So panel data analysis is a special branch of econometrics which can deal with this type of pool data which varies over time as well as across the units. Okay, so this is our agenda for the future, and if you require specific discussion on a particular topic, or you want more information, what are the topics I need to cover in econometrics, then you may please give your feedback either in this channel or in my email ID given on the screen. So thank you for watching this video. Thank you.